So in previous video series, we were talking about creating one of those LED displays using shift registers or different LED drivers. So right now what I have in my hand is shift register 74HC595 8-bit shift register. And these components or ICs are not that very expensive, easy to get it and easy to operate it. So in the short video, I just showed a quick video where I just made a proof of concept how it works. And technically you can use one of these Arduino Nanos or Unos or any different microcontroller to control it. And what I have in hand is not 5mm or 5mm LEDs. These are ones called so-called SMD LEDs, and I have limiting current resistor because this is what I had on hand. So technically for displays we can use so-called WS2812B addressable LEDs, but pretty much we're gonna use something like that in a future series or future videos. So to prove how it works, I'm gonna easily explain it, and pretty much it's explained everywhere on the internet. So I'm gonna power on the device, and what we have here, so-called 3 buttons. Sometimes it's called latch, sometimes it's called register, sometimes some people tend to call store buttons. So we have data clock, we have a data button, clock, and store button. So what it means this. Every clock pulse, we have to determine if we're gonna store some data or not. Because right now, pressing the clock data means nothing, or clock button. But right now we have a data button. And if the button of data is low, it's gonna store a 0. And then every clock cycle, we're gonna shift all the bits. So right now we're shifting only zeros right now. But if I hold high and store the data, the next clock cycle will indicate a high state and it's gonna shift 1 bit. And it's true. And I can do over and over because every clock cycle nothing happens. But if I store, let's say 0, the next shift cycle is gonna just shift the bit. And I can do exactly the same. I can hold it, store it, and cycle it. You can also not only shift 1 bit, you can shift all 8 bits if you want to. So for example, I want to shift only 0. So what I'm gonna do is store 0, cycle it, store it, cycle it, store it, shift, and we are done. So what I'm gonna do is I'm gonna say 1 0 1 0 1 0 1 0 1, something like that. So what I have to do is say 1, store it, 0, 1, store it, 0, 1, store it, 0, 1, store it, 0, and next clock cycle it's gonna give us this. So it was right now 1 0 1 0 1, but in the end, because we shifted more bits than I had to, it came to 0 1 0 1 0 1 0 1. For some reason I might misclick it, or it was the bounce problem because I forgot to implement one of those capacitors to reduce the bouncing. But in the end, you can operate this device without any problem whatsoever. So you can use push buttons, you can use capacitors, you can use anything what you like. But in the end, we're gonna use probably Arduinos or SMD microcontrollers, or even so-called SPI32. Something like that. We might use one of those SMT or ASPI controllers because this one has inbuilt Wi-Fi, Bluetooth, and we can use it to communicate with, for example, display driver whatsoever. So in the end, for simplicity, we're gonna use shift registers and probably one of those SMD LEDs, and probably because those are SMD, we're gonna use SMD probably drivers, and in the end we're gonna make one solid printable circuit board in the future. So as you can see, it's very easy to operate it. We can store it, the data is gonna be 1 or 0, and we can clock it. Easy as that. So thank you for watching, and in the next video series we're gonna connect multiple LEDs. Thank you for watching. See you next time. Bye.